Alright guys, here's your unit review. Exponent and radical unit. Quiz tomorrow. Set of practice problems for you. You work through those. I'll work through them after. This looks just like the quiz. Go. Alright, let's dive in here. I'm going to cross out that zero exponent. I see a negative here. I'm going to put that on bottom. I'm going to multiply together those two coefficients. So I got the negative 24. I'm just going to create a fraction now and move that x cubed down to the bottom to get rid of its negative. Now I'm just going to copy the rest and see where I'm at. I've got a z5, an x4, a y5, and a z. So I'll just go from here. My x4 and x3, I'll subtract those guys. That's just an x with that negative 24 on front. And now that the x went away, there's no more reason for a fraction, so I won't have a fraction anymore. And my z5 and z would make a z6. And then my y5 doesn't have anything, so it just stays y5. Doesn't matter what order you put those in, but the general rule mathematically is you always want to alphabetize those variables. I'm not going to take points off or anything, but that's just a habit you want to get into. Okay, 2. First thing, I'm going to get rid of that zero exponent, and I'm going to deal with any negatives I see. I'm going to move that P3 up to the top. I'm going to move that M down to the bottom, and I'm just going to rewrite all this ugliness. 35 divided by negative 7, that's just negative 5. So now that's not fractional anymore, but there is stuff on bottom, so I do need a fraction, and I'm just going to copy stuff. The M4 moved to the bottom. I had an M5 that was already there. I had an N to the 4th that was already there. And on top, there was a P to the 5th that was already there. And I moved the P3 up to get rid of its negative. So that's the problem without negatives. I'd really want to point out, guys, look how much just rewriting and simplifying it kind of clears up the problem for you. Now all my P's are going to go together. That's going to be a P8. So there's my negative 5 copied, and I've got a P8 on the bottom. Put all those M's together. That's an M9. And I got my N4. There you go. Simple. Simple as that. Okay, next one. You can go 2 routes. You can start with this guy and distribute all of that through. That's fine, but I like to do any of the reducing work first to shrink things down. So I'm going to look at any of this top to bottom stuff to subtract, deal with any negatives first. I think that'll be easier. Get rid of that 0k, and I've got a j to move up to get rid of his negative, and an m to move down, so I'm going to do that now. There's a j5 that stays, and a k3 that stays. And then I moved a j4 up to the top. And on bottom, there's an M6 that stays. You guys got to watch the details. You got to look at everything that's there. I think that's probably half the problem with some folks is you just aren't careful to watch. And that M to the negative 4 got brought down. So there we go. And then just don't forget, this all has a third power that it's going to be raised to. And now we can do that piece with the distributing. We're just going to take that 3 through to everybody that's left. And actually, I could have and should have just subtracted those. That would have been a better route to go. You guys are smarter than me. You probably did do that. But now that I'm on this path, I'll continue. It works either way. So I've got a j to the 15th, k to the 9th. Remember, this is multiplication. It's power to a power. I'm taking multiple groups. I'm taking 3 groups of each of these exponent values. That's why it's a multiply. On the bottom, I've got an M6 times 3, so M18. I've got an M4 times 3, so M12. And now my final step, I can do those subtractions or adding, whatever there's got going on. 15 J's and 12 J's is 27 J's. m's on the bottom. We've got 18 and 12 makes a total of 30. And the k's didn't have anybody to connect with, so they just moved to the answer. There you go. Let's look at some radicals. Radical preview, well, you work, I'll come behind you, go. All right, square root of 49 is just 7, whether you just know that or you want to break that down. 49 is 7 times 7. Anytime we have a pair of something under our square root, we take one of them out, or you just know the perfect square, either way works. 81, 9 and 9, also a perfect square. Either way, that becomes just 9. Okay, number 3 starts our square roots or radicals of imperfect squares. So you've got to find something inside to pull out. I'm going to break down that 40 into a 4 and 10. And if you see that the 4 is your perfect square, you can take it out now. Or you can think of that as 2 and 2, and the 10 is 2 and 5. There's a pair of 2's I can take out. So that becomes a 2 out front. And then I've got the 2 times 5, or the 10, that's still locked underneath. And then the y3, to expand that out, can take a pair of anything out. It becomes 1 of that value out front, so I can pull out 1y, taking the square root of that y squared. The other y gets stuck underneath. All right, number 4. Did you notice it's a cube root? We need to find 3 of anything we can take out. So let's see, 2, I know it's an even number, times 27. 27, 9 and 3, 9 is 3 times 3. 1, 2, 3. There's my 3 3's. I can pull out that group right there. So I can pull out a 3 as I take the cube root of those 3 3's. And all that's left, the only branch value that's left, is that 2. So he has to stay inside. Now I can work on all those variables. M6, it's a cube root, so that's 2 groups of 3. Let's give ourselves a little more space. I can pull out 1m, pull out another m, and of course those will need to go together, become an m squared. P5, there's 1 group of 3 in that P5. So we can pull a P out as well. Didn't give myself enough space. There's 1 group of 3. Take the cube root, that's the 1P left out front. 2 P's can't come out, they stay underneath. And R2, 2 R's, but we need 3. We don't have 3, so that R squared has to stay underneath as well. Final answer, we'll just say 3 and put the 2 m's together, 3m squared p. And then everything under the radical. We got a 2 p squared r squared. All right, now, same thing, 5 and 6, except we've got something out front. So 27, we've seen that before. There's 3 3's, but it's a square root, so we're only taking 2. There's the -5 that was already out front. Now we're going to pull out the 3. And the remaining 3 that we can't pair with anything has to stay underneath. X3. Okay, we're taking a group of 2 out of the 3, meaning one of them has to stay underneath. The 2 we can take is a square root, leaving that x on the outside. And then a single y. There's nothing to pair it with, it has to stay inside. And now at the end, the only difference between the previous number 4 and this one, number 5, don't forget, any factors out front just multiply with anything you took out. And there we go. Okay, number 6 is the same as the other problems. Notice a cube root. Notice that 9 out front to multiply. Otherwise, it's exactly the same. 48 I'm thinking of as 4 times 12. Okay, there's a pair of 2s that I'll be able to pull out, and maybe there's more. Let's see. There's another pair of 2s, and all that's left at the end of the branches is that 3. So let's rewrite it down here. We have the 9 out front. We have one pair of 2s that takes a square root out front. Another pair of 2s that's another square, or excuse me, I just made a mistake. Did you guys catch my mistake? That was not on purpose. I wasn't watching what I was doing. I can't take out pairs of 2, can I? I need pairs of 3, or groups of 3. So actually, I should have taken those 3 together, and that's one of the 2s I take out. So maybe you guys make a mistake like that. You can watch and keep that from happening as well. So there's the one group of 3, because it's a cube root problem. This is what I was not noticing as I worked. So there's a 2 and a 3 left over. So that's my 6 that stays underneath. And I can only take out that 1 2. P's, I've only got 2 P's in the problem. I need 3, so the P's can't go anywhere. And my group of 3 R's, I need 3, so that one R can come out. And there we go. 9 times that 2 is 18, with an R, 18R, and everything else stays inside. We've got that cube root of the 6 P squared. There you go. All right, final set. Work those out. I'll come behind you in a minute. All right. I'm going to break these guys down same way we always do. It's 4 and a 5. Just my pair of 2s and the 5. I can pull the 2 out from that pair, leaving the 5 underneath. Okay, there's my square root. There's what's left underneath. So in order to move forward on this problem, just kind of a check on your understanding, that's what I'm going to need to see. The whole concept is like terms with these radicals. So I have to see another radical 5 in a minute, or else they're not going to be able to combine. So that's what I'm going to look for as I go. 9 and 5, and that's a 3 and a 3. There's my pair to pull out, and there's that 5 I need that's going to stand to the radical. Okay, I've got that minus 4. I'm going to bring that down. Okay. And then there's the pair of 3s I can pull out, which needs to multiply with anything on front. And so real quick, let's rewrite this. We have 2 radical 5. Minus, and the 4 times 3 minus 12 radical 5. Now it's just like a like terms problem. We're just putting it together, just like you always do when you're solving an equation. We're going to have some amount of radical 5s. We're really just putting together the 2 minus 12, which is negative 10. There you go. Second one, same idea. That's going to be a 25 times 3. There's my perfect square. It's a pair of 5s. So there's the negative 3 I'll leave out front. There's the 5 I'll pull out. And what's left is that 3. So again, that's what I need to see on the next problem. There's my plus 9. And let's see what we can find underneath there. 48 is 6 and 8. That's a 2 and 3. That's a 4 and a 2. And that breaks down to another pair of 2s. Let's see what we've got. I've got one pair of 2s there. And we've got the other pair of 2s right there. And that might be hard to see, but notice the only other branch that's left is that 3. The 6 broke down into further stuff, so did the 8, so did the 4. So I can pull out one pair of 2s, another pair of 2s when I take each of those square roots. Those are all going to multiply, all those factors up front. And all that was left to stay inside was that 1, 3. Let's rewrite it, and let's see what we've got. That's going to be a negative 15 radical 3. That's 9 times 2 is 18, times 2 is 36, radical 3. So again, We've both got radical 3's here, both terms, so we're able to put together our negative 15 and 36. What's that going to be? 25, 35, 21. Subtract those good guys and bad guys, remember. This is what we're actually doing. Since they're good guys and bad guys, they're going to fight. We're just doing the subtraction, and then we're more good guys, so it's a positive number. And there you go. All right, good luck on the quiz, guys.